Today we're going to talk about Flipper, a debugging platform for your mobile, desktop, and any kind of other hardware. Just a simple debugging app that you start to take a peek inside of your application. But if it didn't work, it wouldn't be the end of the world. You can always use console log. And what we try to do, we're trying to push Flipper to your CI, to your cloud. We try to encourage people to start using Flipper in various automation scenarios because Flipper has access to a ton of information. And in this talk, we're going to review a couple of cases of how you can use this information from Flipper. But before we get started, let me introduce myself. My name is Andrey. I'm a software engineer. This is me looking very serious somewhere in the mountains. And I work on Flipper at Meta. And the plan for the day is to introduce Flipper, I'll talk about what Flipper is, then we'll cover how we introduced API to Flipper, and last, we'll talk about how we use that API at Meta currently. And Flipper is actually, I think this is a good time for a question. How many of you folks know what Flipper is? Cool, that's so much more hands than it was at the last conference. Okay, Flipper is a platform for debugging iOS, Android, and React Native apps. Yeah, right. Yeah, I've heard a good laugh. Finally, this is the first time the audience laughed at this. So yeah, Flipper is kind of Devtools, Chrome Devtools for your mobile hardware. Yeah, and I'm sorry that my slides are much less fancy than the slides of the previous speaker. Yeah, but yeah, I'm kind of a dinosaur, I have a confession. So this is Flipper. This is Flipper allowing you to kind of take a peek inside of the layout of your application. And this is also Flipper exploring the state of the network. This is also Flipper fetching the logs from the device. And this is actually also Flipper. That's one of the plugins that we use for the internal testing when we do our releases. And well, if you use Flipper regularly, you know that sometimes Flipper crashes. So we clearly are not doing a very good job. Yeah, okay. Flipper is actually a device discovery service with a message bus. And the power of Flipper comes from its plugins. And to kind of have a better understanding of what it means, let's take a look at the Flipper's architecture. So we have Flipper, the dolphin thingy, square in the middle. We have 3 devices. And the way Flipper does device discovery is it's using ADB for Android under the hood, IDB for iOS, and Metro for React Native. That's the way that Flipper sees the world and finds the devices. And we also have a desktop view, web view inside of Electron that shows all these devices. So let's imagine that we have device A, B, and C. And on the other side, it's very confusing that my right is left here. Okay, so we have A, B, and C devices there, and then we display them in the desktop app. And once the devices are discovered, Flipper starts so-called device plugins. Don't worry, we'll cover what the plugin is and different types of plugins later, a bit later. And the best part, actually, is that, well, devices can be running different platforms, Android, iOS, React Native, and now even JavaScript, or maybe any kind of C++ application. Actually, inside of Meta, we have, I think, at least 2 clients that use pure C++ implementation of our Flipper client. And the best part is that you write the desktop part of your plugin, which is the biggest and the most complex part of your plugin, only once. And then it runs on any platform. Yes, you have to add a bit of code for every platform to kind of push the data to desktop, but usually the most complex part is the desktop part. And yeah, I haven't mentioned that Flipper is open source. Yeah, Flipper is open source, and my memory is kind of crap. And the plugins, lots of plugins, they are open source as well. So for instance, our logs plugin that we saw earlier, our CPU plugin, you can find the source code at these links. And yeah, I promised you to show how simple the client side of the Flipper plugin is. So once we remove all the boilerplate, that would be the navigation plugin for iOS in a nutshell. That's pretty much it. You just receive a message and you just say, you just tell your application to go somewhere, navigate to a certain screen. As simple as that. So not too much code. And we'll see how complex the desktop part could be a bit later. However, it doesn't really have to be very complex. We have a couple of high-level primitives that allow you to build your desktop part of the plugin fairly easily. Alrighty, so if we stopped at the device plugins, then Flipper would be only flee without pair, kind of half of the Flipper. The best part of Flipper is when we start adding custom integrations with the applications. And that works in kind of a different way. So, well, at this point, we already have discovered the devices. And these devices, they start their applications. And these applications, they have dolphins of their own. They have Flipper clients. And these Flipper clients, they connect our WebSockets to our WebSocket server that Flipper hosts. And that's how we discover the applications that your device is running. And here we have 3 different applications of unknown origin. And yeah, they connect to Flipper via WebSockets, and we display them in Flipper UI. And we create a message bus between Flipper UI and the device. And that's, in my view, that's how I like describing Flipper. That Flipper is basically a message bus, universal message bus for any kind of your hardware and your desktop. And then whatever you do with this message bus, whatever you do with these messages, is pretty much up to you. We just provide a set of primitives and the kind of boilerplate stuff to intercept these messages and to act on them. But then it's up to you what you want to do with these messages. And when the devices are discovered, when this message bus is created, we start the plugins, we start the desktop part of the plugins, and the desktop part of Flipper commands the device to start the device part of the plugin and start pumping the data from the device to Flipper. Yeah, these are the plugins. And they start exchanging messages, effectively kind of sending commands, sending data, and in the end, you see the data either in a table or any kind of custom UI that you can build inside of your React application, which is what Flipper UI is in the desktop. And this is where you can let your imagination run free, and we can kind of fantasize of how Flipper can be used, really. But before that, I mentioned that I'm mostly using console log to debug, and I'd like to see some hands of how many of you guys are fans of good old console log. Yeah, that's more like it. But yeah, console log is great, or printf and C, whatever you used to. But imagine if you could kind of see the state of your application live at any point in time without running yet another console log statement, without rerunning your application. And that's totally possible with custom Flipper plugins. At Meta, we have hundreds of plugins for a variety of different applications that we use externally and internally, and they basically just take the entire state of the application and dump that state in Flipper. And then, well, you can see, at any point in time, you can see the state of the application. How cool is that? Or you can tell your application to navigate to a certain screen, and we saw the part of that plugin from the native side before. You can also emulate some hardware signals. Well, for instance, take this wristband. It's not developed by Meta, it's Xiaomi, I think. But imagine that you have, well, you're developing a new wristband, and the hardware is still an early prototype. You just settled on a protocol, and you're developing a companion Android application, and you don't really have the hardware yet to ship to your developers. What do? You need to somehow emulate signals coming from your hardware, and you can do that with Flipper because it's effectively a message bus, and nothing prevents you from sending custom messages to your device, kind of simulating the protocol, and then using these messages to replicate the state of your application that interacts with this custom hardware. Another thing, you can also kind of command your device to do anything, pretty much anything. Well, the navigation plugin commands it to go to any screen, but you can also use it during testing to, I don't know, do some weird stuff. Okay, and now let's go to the second part, where we'll discuss why we had to kind of rethink what Flipper is and how Flipper evolved to support all these new scenarios of automation. And, well, consider this fairly simple setup. You have Flipper, you have your desktop, it works just perfectly. Cool. And what it actually is, currently it's an Electron app, and inside of that Electron app you have a node.js process that hosts that message bus and device discovery and etc. And you have a web view which runs a React application, and they talk via some Electron magic. And in that setup, what if your simulators, they're somewhere there in the cloud, not locally? How would you connect Flipper to these simulators then? Well, that's not too much of a problem, probably, because you can always do some SSH magic and forward the ports from your cloud to your local laptop, and then ADB and IDB are going to work, which is lovely. But then the next scenario comes. What if you have your single laptop and you want to work with some remote developer environment? What if your company has remote developer machines that run VS Code in headless mode and provide you some powerful setup and then just give you a crappy laptop to connect to that thing? How would Flipper work then? First of all, how would you kind of see what Flipper sees in the cloud? Oops. And then another problem is how Flipper would connect from that remote machine to another remote machine in the cloud with the simulators. Yeah, the second part of the problem can be solved once again with SSH, but then how would you kind of see from your laptop what happens there in the remote environment where your VS Code runs? Yeah, you can use RDP, but can I see some more hands? Who likes RDP? Yeah, that's what I've been thinking. Yeah, actually, I think that it's great tech. It's just probably me kind of being lazy to set it up properly, but it's always laggy for me. Hate RDP. And the last scenario, automation. How would you kind of teach your robot, your script to interact with this imaginary RDP? Like really click on some pixels here and there? Just, well, it could be cool. I'd be up to implementing that thing, but no sane company would ever pay me to do kind of image processing, trying to figure out the buttons to automate some Flipper scenarios. So yeah, the same problem, essentially. Yeah, lots of questions. And the way that we decided to approach it is to kind of decapitate Flipper. As we remember, it's kind of a Node.js process and a React app, and they're connected via some sort of electron magic. What if we replace this electron magic with any kind of other magic, like WebSockets, for instance? Then we could place the head of the Flipper, the UI, on our end, on developer's laptop, or teach our script to use it somehow, and then the bottom part of the Flipper somewhere in the cloud where it could freely connect to the devices. And the same setup would work perfectly with remote machines, with remote developer environment. We would have our web UI on our laptops, and then the bottom part of the Flipper, the Node.js process somewhere remotely connecting to our cloud. And one more benefit would be that since it's going to be a web app, we can now use our favorite iframes to embed it anywhere. Anywhere, anything that runs web can now display Flipper UI, and that allows you to kind of embed Flipper into VS Code, for instance, if you're not a fan of having multiple windows. Personally, I don't have a problem with having multiple windows, but I know that some folks, they kind of like have this monster with lots of tabs. But as long as it's a single window, they're happy. So who am I to judge, really? And yeah, that's how it works now. We currently ship 2 versions of Flipper. One version is an Electron app, and the other one is a Node.js app that serves the web app, React web app, and they talk over WebSockets. And here is the part where we talk about API. You remember that robot hosting the head of Flipper, but head of Flipper is UI, right? So we'd still have to teach our script to somehow click the buttons, which is not really something I'd like to do. Well, okay, that's something I'd like to do. That's not something my company would like me to do. And let's recollect the architecture. So yeah, we have the message bus, WebSockets, blah, blah, some UI devices. And the problem is that, as you can see, plugins, they are drawn inside of the UI part. And that's not a mistake. That's done on purpose. So the state of every plugin, for historical reasons, it doesn't live on the server side. It lives on the client side. And that's actually a huge problem. Because now when you replace the UI with some sort of headless client, say your terminal, you still have to host these plugins inside of that terminal somehow. And that means we can no longer share the code of Flipper. Kinda. Well, we could share the code from Flipper UI that manages all these plugins from Flipper, but then we would have to make our headless client a Node.js application. And the problem here is with Node.js, not everyone is a huge fan of JavaScript. And yeah, probably this is the wrong audience to ask who likes JavaScript. But I promise you, when I give this talk in front of native developers, it makes much more sense. Well, nevertheless, if your company has different folks, different developers, not everybody likes JavaScript. So it would be a shame to force people to write JavaScript to connect to our headless Flipper. So another option is that kind of to shift our thinking. We already have a Node.js process, right? We already have Flipper. So could we somehow, with certain restrictions, move the state of our plugins to that thing? And the problem is that we really want to be kind of backwards compatible, because if we tell our developers plugin developers to rewrite all of their plugins, probably it would be the death of Flipper. What we've done, and I'm going to show you what we've done on the example of that tic-tac-toe plugin. Essentially, we kind of moved the code to our Flipper server part. And well, I'm trying to remember what to say next. Yeah, so we moved the code there, and we created some sort of an RPC or yet again WebSockets. When you have any kind of asynchronous function and you can serialize the input and you can serialize the output, you can always create some sort of an RPC. You can just serialize the data, send it somewhere, run this function somewhere else, then create the promise on your client side, and then promise is going to wait when your network returns the serialized reply, and then you resolve that promise, and voila, it looks like you ran this function locally, when in reality, it went over the wire. And to demonstrate how it works for our tic-tac-toe plugin, let's go through its structure. And yeah, I promise you to take a peek at how desktop part of the plugin could look like. So this is tic-tac-toe, the desktop version. Let's go over it line by line. So we create the state, some sort of initial state of the application of that tic-tac-toe board. Then we have various API calls like send update, make move, reset. We do some unspeakable things when this onConnect call happens, and then we return the API. Going through the API itself, in make move, we basically check the state of the application, and if it's correct, we compute the next state, and we send this state to our mobile phone. Send update, it's really straightforward, just kind of send the message to your mobile. And the unspeakable things inside of the onConnect. When we receive a message from the mobile, make a move and can calculate the next state. And when we receive another message, kind of a request for the state, we send the state to our mobile. And once the plugin starts, we proactively send the state to our mobile. And the UI of the plugin is pretty straightforward. We use a couple of hooks to consume the state of the plugin, and then it's a simple React application where we just iterate over the cells that we have in our state. And this is new stuff. This is actually how our headless mode looks like. Now, from a Flipper plugin, we can export one more function, and it kind of whitelists or maybe transforms the API exposed from our plugin instance, the first function that we saw before. And that's pretty much it. So how it works, as I said before, we have our CLI, our headless client. It thinks that it runs the same asynchronous function locally. But what happens in reality, we create a WebSocket tunnel, we serialize the input, pipe it there to Flipper server runs the function, serializes the output, pumps it back, and there we go, we have kind of RPC, essentially. And demo time. Yeah, I'm too much of a chicken to do it live. So it's going to be video. So this is me playing tic-tac-toe on my mobile with me on desktop. And yeah, I like winning, so this is me winning the game of tic-tac-toe, hopefully. Why am I losing? Too confusing. And now, this is the same game played from my terminal with my mobile using the headless API. When we host that API calls on the Flipper server side. Yeah, making some moves. Yeah, I won, finally. Good. Okay, and the last bit, how we use it at Meta. One of the first implementations that was we originally had in mind when we implemented that thing was design verification. We usually get some cool designs from our creative guys, and we do our best to implement them somehow. And usually, they want to verify that we've done our best and that it, at least to a certain degree, matches the expectations. And how it works now. Any developer, once they finish the implementation, they can type a simple command in their terminal, and that command sends a message to Flipper to start our UI validation plugin. That plugin, in its turn, goes to the device, makes a screenshot, gets a screenshot back, and submits it to the cloud where we have our VCS running, and then a designer can go to our commit and see what's the actual implementation. And another scenario that we have and that we're currently exploring is testing, and that one I like kind of more. So what we have now is we have probably thousands of end-to-end tests. I don't know the exact number. And the way that we run the end-to-end tests now is, once again, in our terminal we type some command, it spins up the entire test suite somewhere in the cloud. That cloud test suite connects yet to another cloud with the simulators, runs the tests there, fetches the data, runs some assertions, and then displays the result of the test run in our web UI. And what we've done, we've decided that it would be pretty cool to host Flipper next to the simulators. When our test run fails, we can always go there and see what went wrong. Before that, usually what we had to do is to rerun it manually on our local machines, and sometimes the errors, they were not reproducible. Then you have to add some console logs, fetch the logs, and now our developers can just start Flipper and replay the test run and see what happens there live. But that's not the end of it, really. You can see one more head of Flipper in that cloud thingy, where we have Jest running our test suites. So we already saw that Flipper possesses lots of data, right? Flipper can speak inside of the state of the application. Flipper can command devices to do anything. What if you could use Flipper in your tests? Imagine that you could fetch the state of your application and then basically compare the snapshots between your previous test runs and your current test runs. For instance, well, you click some buttons and then you don't just compare the screenshots, you also compare the state of your application, like serializable thing. Or maybe, what if you have some kind of custom hardware and you could, well, you have an application once again, right? And you want to run an end-to-end test with simulated hardware. You could use Flipper to send a message pretending to be that hardware and then expect something to happen on the device. So yeah, once again, the potential here is pretty much unlimited. We haven't really implemented that bit yet. So if you decide to give it a try, we would be very happy to hear from you on our Twitter or on GitHub. Whew, I think that's the end of it. A couple of links are the demo for our headless tic-tac-toe and another simpler demo. They're available in open source. Yeah, feel free to reach out to us. GitHub and Twitter. Feel free to ask any questions, once again, on GitHub or Twitter. This is legal stuff, so we don't get sued. And yeah, the QR code leads to the slides. Thank you all.
So really quick one. So you have all these plugins running over the server, and they used to run it within the Electron app before, right? So they could access the file structure, network trace, and now they're doing that through the server.
It's kind of weird now. So the app, the plugins, they still can run on the client side in the UI, but now they're ambiguous. They don't care about the environment. We created a host environment for them on the server side, and they can also run on the server now. And well, before that, they actually couldn't really access the file structure directly. Maybe they could, but we removed that. So now we have an API, WebSocket API, that exposes a subset of Node.js APIs and basically does the same thing. Any kind of plugin can use that VC-like API to like pretend that it has access to file system, when in reality, Flipper server has access to the file system, and it exposes the API to the plugins to get to that file system.
Okay, so does that mean the plugins are starting a lot of processes, like additional processes, and then we have to be the ones? I mean, how is it controlled? Because it looks like it's request and then a response loop, right?
I'm not sure I get the question, really.
So the plugins would start additional servers because they can?
No, not really. They reuse the same server. So we have Flipper server that hosts the device discovery thing, and that hosts the WebSockets thing. And the plugins, they connect to a single Flipper server via WebSockets. So you don't really need multiple Flipper servers. You need only one. That's a single point of pleasure and failure.
Thanks for your talk. I would just say I found the lady's slides equally as interesting as yours earlier, because you said that yours were a bit more detailed, but I found hers quite detailed too. I just need to understand, like, why would I not use React Native debugger? I mean, we all understand what Meta is, but why? Like, I have worked at multiple companies using React Native, and nowhere in sight is the word Flipper mentioned. So tell me why.
I think the greatest benefit of Flipper is that it's mostly platform agnostic. So if you have a single platform and you have to debug a single platform, then probably it doesn't make too much sense to use Flipper unless you already built some plugins for it. So I think that.
What do you mean by single platform?
Well, you said React Native, right?
Yeah, I'm just asking what you mean by that.
Okay, yeah, that's what I mean. So if you're developing on the React Native application, then you can use pretty much any tool that you're comfortable with. And another thing would be that, well, you could have not only React Native applications, you could have also native applications. You could also have some desktop applications, and they might share the same state, so you can write your plugin only once and reuse it everywhere. And I think also probably the existing plugins, they play a huge role here. So if you're comfortable using React Native debugger, that's absolutely fine. But I think that the ease of developing custom plugins, that's the great benefit, the biggest benefit of Flipper. If you want to create custom debugging DevX experience, for instance, to take a peek, to dump the state of your application, as we discussed before, well, you have like that complex distributed state inside of your application, like various pieces here and there. And with Flipper, you could see the state of your application live if you write a custom plugin that fetches these bits and pieces and dumps it to Flipper desktop. But in Meta, I think that the primary reason why Flipper kind of became popular is that because we have plenty of native applications. And money, yes, obviously. Obviously, yes. We have plenty of native applications that do the same thing for different platforms. And then, yeah, the developers, they write the desktop part only once, and then we can reuse the same desktop part.
Two questions. One for, in case of multi-user, multi-device, how the plugins are performing?
What if you connect several phones? Okay. Basically, it would be different instances of plugins, so they completely separated.
So for each end user and for each pair of user device, an instance of a plugin will be.
Yeah, so as we saw, plugin state lives on the client. So while every mobile phone, every app is a different client, it means that it's going to host its own state. And well, if you have another desktop client, I think that's what you meant by user, right? Then once again, you have a different state.
And the second one, regarding let's say the most important part in the React Native is the state, obviously Redux or whatever, and APIs to debug. And I know for a fact that Reactotron is a plugin for Flipper.
Probably. Sorry? Probably.
Yeah, okay, it's hundreds of plugins. By the way, do you have suggestions on the APIs plugin, best APIs plugin? To debug APIs, right? To intercept Axios calls.
Oh, well, actually, I work on Flipper core and I rarely develop plugins themselves. So I wish I had more info about that. Well, yeah, we do have that network plugin, so you could probably just take a look at what happens there. But honestly, yeah, I think it's pretty complex. But it should be open source, so you should be able to just fork it and do whatever you want with it.
Hi, just wondering, are there any plans to sign the Mac desktop app anytime soon?
Yeah, we've done a terrible job of interacting with our open source community. Yeah, I'm going to raise that question at our next meeting.
Thanks. Great talk. One quick question. What's the fastest way to get started with open sourcing with Flipper?
Probably head out to our website, and we have quick start guide there. It's fbflipper.com.
One last one on my end then. So just looking at this, I'm just curious, how well does this play with Expo? Because I know sometimes Expo with certain dependencies is not friendly.
And this is the moment when I should be really ashamed.
Okay.
Yeah. What's Expo?
Fair enough. That answers the question then. All right, give it up for Andrey.